right, we're going to continue our conversation with circuits, and we're going to talk specifically about circuits that are set up in series. And if a circuit is set up in series, it means that it's wired so that from the battery back to the battery, the current only has one single pathway it can have. Okay, so this is an example right here. And if you look, you start at the battery terminal here, and you're going to go through the switch, and then through this light bulb, through this light bulb, through this light bulb, and then back to the battery. So that's a single pathway. All right. Now, if we were going to draw it in a different way, we could draw it like this, where we have these resistors set up, or you could say these might be batteries instead, and this is the resistor. And so if there's a single pathway through that resistor. Then if we look at it like this, again from the positive terminal, because current always travels out of the positive, goes through this circuit, or that resistor and that resistor, those light bulbs, and comes back. When we do this with our schematic drawings, this is what it looks like. So we have our battery right here as a long line and a short line with a positive and negative. We have our current going around out of our positive. We have our resistor, which this could be a light bulb, and so if there's a light bulb, we could put a circle around it. But these actually are just resistors since they don't have circles around them. And we have connector spots, and then we have the current finishing over here in this direction and going into the negative. So single pathway. If you can trace from the battery all the way back, and it can never go the other direction, that's the other thing. So that would make it series. Now we have some rules for when we have resistors in series, and these are really important. So if at any time you need to have it paused so that you can make sure you get these written down in your notes, you need to. Okay? In a series circuit, the current is the same at all points along the wire. So what that means is whatever you figure out as the total current, then through the first bulb is the same amount of current, and through the second bulb it's the same amount of current. And that's because it has to go through every one of the resistors before it gets back to the battery. So the total current is going to equal the current through one resistor, the current through two resistor, the current through three resistor, so on and so forth. You have the big stars around this, by the way. Okay? The other thing to realize is you can find total current by doing the total voltage divided by the total resistance, which we'll talk about here in a little bit, how you can get the total resistance. The total current, the total voltage is going to be what the battery is. And so whatever the battery is going to be your total voltage. Now, for the equivalent resistance, this would be another way of saying the total resistance of the series circuit. So the equivalent resistance is really just the way to make it look like all the single resistors could be replaced with one single resistor. So all the individual resistors could be replaced with one. And if we were going to do that on a series circuit, you would just add the resistor values together. That would create your total resistance or your equivalent resistance. And this is depending on how many you have, you just keep adding them together. All right? So then also the sum of the individual voltage drops that happen across an individual resistor, if you take all those voltage drops, then you can get the total voltage by adding it together. Again, that total voltage is going to be what your battery is, and then the voltage drop is going to be found by doing the, remember we can find V equals IR, so we can find the individual voltages by just doing the total current times the individual resistor. Because remember, the total current is going to be what every other current is as well. So you could also use V equals IR to find the individual currents, but or the individual voltages, but you'll just take the current, the total current times the individual resistor. Okay? So, again, if you didn't get those rules, have the sub pause it, pop it back, and get that information written down. Let's do an example. We have two resistances of 2 ohms and 4 ohms, respectively, that are connected in series, which means they have a single pathway. If the source of the EMF, or the electromagnetic force, or the potential difference, maintains a constant potential difference of 12 volts, so the EMF is really just a battery, by the way. I want to know what the current delivered to the circuit is. So, to find the current, you have to have the overall resistance. So we're first going to have to do the, and I like to draw it. I'm going to back this up for just a minute. I really like to draw it first. And so we're going to have our battery, and then we're going to have a resistor, and then we're going to have a resistor, and then we're going to go back to the battery. Remember, this is the positive, this is the negative. Our current goes around this direction, comes back this way, okay, goes through here. So it always goes out the positive and into the negative. This is going to be 2 ohms. This is going to be 4 ohms. So the first thing I want to do is find my total resistance, or what we call our equivalent resistance. So we're going to take our R1 and our R2 value and add them together. So we're going to take our 2 ohms plus our 4 ohms, and our overall resistance should be 6 ohms. Now if we want to find current, current is going to be our voltage divided by our total resistance, where our voltage is 12 volts. So we're going to take 12 volts and divide it by 6 ohms. That's easy enough, and we come up with our current value to be 2 amps. And that would be as it goes around. Now I also want to know what the potential drop across each resistor is. And if I want to know potential drop, I really want to know the voltage of each resistor. Well, I know that the individual voltage can be found by doing the total current multiplied by the individual resistor. So my total current is 2 amps, and the first resistor is 2 ohms, so my first voltage drop would be 4 volts. Then, for my second voltage drop, I would do the total current multiplied by the resistor 2, which is 4 ohms, so I would have 2 amps multiplied by 4 ohms, which would give me 8 volts. If I check that, the total voltage should equal these added together. So my VT should equal my V1 plus my V2. Well, 4 plus 8, let me go back, sorry. 4 volts plus 8 volts equals 12 volts. And that value is the same as my actual voltage that I was given. So that's just a way to check it. Okay? Again, if you need to pause it, go back and look at it again. Definitely do so, but make sure you get this in your notes. You now are going to be working on some worksheets that you're going to have to find the total current, the total resistance, the total voltage, and then you're going to have to find the individual amounts for each one of them. So if I'd asked, what's the current through the 2 ohm resistor? You should have been able to tell me 2 amps. What's the current through the 4 ohm resistor? Should have been able to tell me 2 amps. So have fun with the worksheet. The answers are posted in the support station in the back of the room. You guys work together and take care of each other. Remember, you cannot work at the back of the room. You can only work at your desks, but you can work together. No phones. See you soon.